Huh? Mirror formula. Okay, let us start with mirror formula. So when we are deriving the mirror formula, all of us know very well that mirror formula is given from 1 over f is equal to 1 over e plus 1 over b. 1 over f is equal to 1 over u plus 1 over b. So we want to derive 1 over f, derive a formula such that we are going to end up with 1 over f is equal to 1 over u plus 1 over b. So for this case now, we have to start with a diagram. We draw rays of light, and we have two different types of mirror. We have two different types of mirror. We have concave mirror and convex mirror. So consider this is a core principle of how do you call this line?
Principal axis.
Principal axis. So this is the principal axis, and then now we have a concave mirror. And under the concave mirror, this is the pole of the mirror. Then we have, let's say there is an object here. And then we have C, center of curvature. Then F is the focal length. Such that this F, you can draw any ray. There is a rays passing through F, rays passing through C. So long as you can come up with a full diagram of reflection. Like now, if we draw a ray passing through, let's say,
let's use a ray parallel to the principal axis.
A ray
parallel and close the principal axis.
Parallel to the principal axis, this ray, yeah?
Which is reflected through F.
Which is
focal.
Reflected through
focal point.
Through F.
Then a ray passing through C.
Then we have a ray passing through C.
Which is undeviated.
Which is going to be undeviated. So if it is this way, again make that way. So in that case, we are going to have our image at this point. Are you seeing? Are we together? So this is our image. So we can call this one I, and this one is I prime. This is our object. In fact, let me just use this is A, then this is B. This is our A prime, B prime. So that the point at which this one passes, this one can be our D, and you can cross this one that way. So yes, for those who have just arrived, we are deriving the mirror formula, essentially the mirror formula. And when you are asked to derive the mirror formula, what should come into your mind is the properties, the similarities of triangles. So we're going to consider the similarities of triangles after drawing the diagram. So this is what we're going to do. Now we have a small aperture here at the center of the mirror. We can call this one E. So if you look at this diagram, we can obtain that all distances are being measured from the pole of the mirror. All distances are measured from the pole of the mirror. So when we are going to take now from P, which is the pole of the mirror, to F, that is the focal length, and therefore you say PF is equal to focal length. But for this case, because we want to derive a mirror formula, now we just introduce negative for each and every element. Like for this case, we are talking about F. So this one is going to be negative F. P, F. From the pole of the mirror to focal length, that is what we have focal to F is focal length. And for this case, we are going to introduce negative. We are going negative F. Then the distance from the image to the pole of the mirror is the image distance, and the image distance is denoted by V. And therefore, we are going to have PA prime is equal to V. But we say for this case, just include everything to be negative. So it's going to be negative V. Then, this is our object, AB. AB is the object, and A prime, B prime is the image. So the distance from the pole of the mirror, which is P, to object is object distance, and that one we call U. So which is P to A. So PA is equal to U.
Negative U.
And for that case, just introduce negative. Then we have the distance from P to C. This C is the center of the curvature, and we say the center of the curvature is the center of the sphere of which the mirror is part. So C is the center of the curvature, and therefore P to C is denoted by negative R. It should be R, but we say for this case everything should be negative. So negative R, which is the same as 2F. Are we in agreement that R is the same as 2F? So for this case it's going to be negative 2F. Then now we have, because now our formula only involves F, U, and B. So we have the value of F, U, B, F. Now, so I said that when you are dealing with a diagrammatical derivation of mirror formula, we consider the similarities of triangles. So first of all, we are going to look at two triangles that are similar to each other. Triangles that are similar to each other. Triangles like now, I think this triangle ACB is similar to triangle A prime CB prime. Triangle ACB is similar to triangle A prime CB prime. These triangles are similar in that this angle is the same as this, isn't it? And this one is also the same. Opposite angles are equal. And since the two of these angles are equal, corresponding angles are equal, which means all the angles are the same. Therefore, these two triangles are the same. They are similar. So you can just say triangle ABC is equal to triangle A prime C B prime, because they are similar. Once you realize that two triangles are similar, it means that now the corresponding sides, therefore the ratio of the corresponding side of the ratio of the corresponding sides. The ratio of the corresponding sides are equal, which is constant. Such that now if I take A B over A prime B prime should be the same as A C over C A prime. Are you seeing that? Or you can take this A. But now because we're dealing with A, that is B distance. So we're going to take AB. So in this one, we are still under this one. So you take AB. Of course, you're going to that triangle ACB is the same as A triangle A prime C B prime. Now, so we have AB. Since these two triangles are the same, therefore the corresponding sides of the two triangles are constant. Therefore, AB over A prime B prime is equal to AB over A prime B prime is equal to AC over A prime C. So you can call this one. This is our first equation. You can call it this one second equation. 1, 2. So we have AB. Now we know how to identify that AB over A prime B prime is the same as AC over A prime C. Why? Because these two triangles are similar in that the corresponding angles of the two triangles are the same, are equal, and therefore that makes them to be the same triangle. You see, this one has been enlarged such that you can just see it is bigger than this one, but it makes sense that they say because this angle and this one are the same, this one is also the same as this. Of course, this one also is going to be the same because angle inside the triangles always add up to 180 degrees. So we have AB over A prime B prime is equal to A over C, AC over A prime C. Now, so we can substitute. So we have AB over A prime B prime is equal to AC. We have AC. Are you seeing AC? Can we get AC? We say that when dealing with these concepts, what should be in your fingertips is that all distances are measured from the pole of the mirror. So for this case, it is P. Now, AC is equal to PA or minus PC. For us to get AC, it is PA minus PC. So, which is equal to AC, which is the same as PA minus PC all over A prime C. Are you seeing A prime C? A prime C. A prime C is PC minus PA prime. PC minus PC minus PA prime, which is the same as PA is the distance from P, that is the object distance, and we say that PA is negative. Yes. So you just come and say PA is negative U minus PC. PC is the R, negative R, and negative R is the same as negative 2F. We say PC is equal to negative 2F. So minus negative 2F over PC, which is negative 2F minus PA prime. and PA prime is negative B. I think now you know how to arrive in this negative B, PA. So, you can call this one, let's summarize that now we have A, B, log A prime, B prime is equal to negative U plus 2F log negative 2F plus B. So this is done. Now, so that is the first two triangles that are similar. Now what we should need to do again is now look of two triangles again which are also similar. And for that case, we have this one. Triangle D. Having solved the first one, now you look for another triangles, different from the others, but somehow they are the same. If you continue, you are going to see. Now we have DEF, triangle DEF. DEF is similar to this triangle is similar to this one. Triangle A prime B prime F. Triangle A prime B prime F. I see. This one is 90 degrees. This one is also 90 degrees. This angle here is the same as this. And since these two angles, of course, this one is also the same as this. Therefore, since all the angles inside this triangle is the same as all the angles inside this triangle, the corresponding angles are the same. Therefore, these two angles are similar. And they are not only similar, they are also equal. I see. So these two angles, these two triangles are equal, and since they are equal now, the corresponding ratio of the corresponding sides is constant. So the ratio of the corresponding sides of the both two triangles is constant, and therefore you can say A prime
B prime.
Yeah, you can say this one or this. DEF, so we say DE over
A prime B prime
over
A prime
B prime is equal to EF
over F A prime
F. EF
over A prime F.
So there's something that we need to consider. You see, this distance here, this one, is the same as this. Are you seeing that? So instead of DE, since DE is the same as AB. Therefore, you can just say, instead of DE, now we can just say AB. AB over A prime B prime. AB over A prime B prime is equal to EF over A, EF over A prime F. But you see, we have EF, and you see the distances are measured in the cone of the mirror. So, since this one, there is a small aperture, and you can see there is a small aperture here, and therefore, you see that because of that small figure, you see that this distance is now taken from P to F, not E. So, instead of EF, you can just write PF. Are you seeing something? Instead of EF, we write PF instead of this one. Now taking E. Because there is a small aperture. You see this one, it is curved. That's why we are going to take it this way.
Do you mean the length PE is something which we can ignore?
It's somehow equal to EF.
It's just equal to PF.
Yeah.
we can ignore that
Now we can ignore E. I see. Now we are going to have
negligible.
So now we are going to have PF. Now AB over A prime B prime is equal to PF. For us to get PF is just PF. So just take PF over A prime F. A prime F. We want to get this distance, A prime F is the same as P A prime minus PF. P A prime minus PF. Such that we have PF. We said PF is negative F. All over PA prime. PA prime is
negative V.
Negative V minus PF. Negative F.
Negative F.
Which is the same as negative F all over negative V plus F. We call this one fourth equation. Now, what we do next is now you equate the two equations. Equate third equation and fourth equation. Third equation says that AB over A prime B prime is equal to negative U plus 2F over negative 2F plus B. And fourth equation says that AB over A prime B prime is equal to negative F over negative B plus F. When you get this equation, you see this one is going to cancel this. I see something.
Yeah.
When I equate these two equations, this one is going to cancel this.
Yeah.
Therefore, we're going to remain with this is equal to this. So we equate equation 3 and 4. Okay. So we are going to have 3 is negative U plus 2F all over negative 2F plus B is equal to negative F over negative B plus F. Now, what we do next here is just cross multiply. Such that now we are going to have this one multiplied by this. So we are going to have negative B into negative U plus 2F plus, I'm expanding, I see. Because we have this multiplied by this one. So I'm expanding negative B into negative U plus 2F plus F into negative U plus 2F. See there?
Yeah.
So plus F into negative U plus 2F is equal to negative F into negative 2F plus B. Negative 2F plus B. Such that if you open the bracket, for this case, you're going to have B, UB. This is B and this is U. Negative cancel, so you're going to have UB plus minus 2PF. Are we together? Minus UF plus 2F square is equal to negative 2F square minus BF. Are we together?
Yes.
Now, if this, we are now going to have UV minus 2VF minus UF. This one and this is going to. So if this one crosses the other side of the equal sign, it's going to be 2x square minus 2x square. So you're going to get 0. So in that case, this one cancels. So it's equal to negative BF. Now, we have this negative bf and bf, so we can collect like term, because these one are the same. So we're going to have uv minus uf
is equal to negative
b plus isn't it? So itakuwa negative bf plus 2bf, which means negative 1 plus 2 is 1. So itakuwa is equal to bf. Now we can divide both sides by the LCM, or which is the product of UVF, 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 UVF. You have UV, UV, this one cancels, so you're going to have 1 over F minus F cancel this, U cancel this, minus 1 over B is equal to F cancel this, B cancel this is equal to 1 over U. So 1 over F is equal to 1 over U.
Plus 1 over
this one you can close it, the other side of the equal sign is going to be
plus 1 over V.
Plus 1 over
V.
B. So it's going to be 1 over U. When this one closes, the other side is going to be basically 1 over V. Therefore, our main thing is 1 over N is equal to 1 over U plus 1 over B. So that is B. Are we together?
Yes, it will see.
So we agreed that we are going to look at the three derivatives. The first one is under Miller formula. So in this one, it only depends on how you draw your diagram, because there is different ways of drawing diagrams. And for this case, we decided to use concave mirror and array of light parallels with the principal axis, which is this one, and then it gets reflected back passing through F, and this one from the object directly to C. And you can also use the same any diagram. Like now, let's say this is our mirror, and say we have object here. There is cancel this way, we have and then cancel this one to meet somewhere here. Cancel. Still the same, but just apply the rules. So long as you have a correct diagram of array of light passing through being reflected on a mirror. So you just follow this, but for this case you introduce, because you say that PF, we are only considering F, U, and V. And you see FPF, that is all the distances are measured from the pole of the mirror. So that is what should be on your mind. Another thing is that we only consider the similarities of triangles, and considering the similarity of triangles, we are going to end up getting all these things. So you just apply when the triangles. Now that is same, we are going to apply that the same to length formula. So we said that mirror formula, length formula, and another one is the relationship between refractive index and angle of the prism, right? And the angle of the prism. That is just another one that you also need to know, so that you prepare for it. In any case, it is there. You can be able to go through it. So, should we do which one? Which one should we do next? Is it length formula or the relationship between the length, refractive index and that one? Or let us start with that, and then you finish with the length formula. Are you okay? Now, I don't how it is called. How do you call it? Let's do that. Refractive index. And angle of minimum deviation. Angle of minimum deviation. Now, so for this case, when we are asked to derive equation relating refractive index and angle of minimum deviation, first of all, we have come up with a prism. Who can define for us what a prism is? Who can define for us what a prism is?
Surfaces and
Two triangular faces.
So it's a solid figure with two
triangular bases
with two triangular bases and
rectangular faces that are closed.
three rectangular surfaces that are closed. Yeah. Is a solid figure with two triangular bases and three rectangular surfaces that are closed. So for this case, this is just a sample of a prism, and we say that with three triangular surfaces. We said with what?
Two triangular bases and three rectangular faces that are closed.
And three rectangular
Bases.
and two triangular bases. So this is part of a prism. We have a triangle. That's why we draw it in form of a triangle. So this is a base of a prism. And normally a prism, the angle of the prism is obtained at this corner, and it is denoted by A. That is the angle of prism. It is denoted by A. Such that now we can name this one to be A. This is A.
B.
And this is B.
That's
This is
C.
C. So this is a prism, and we want to derive equation relating to refractive index and angle of minimum deviation. Now, first of all, you consider a ray of light being incidented on the surface of the prism. This ray of light, after striking the surface of the prism, it gets refracted. It gets refracted and then emerge out. So you see, this is now take this one as our surface, and the first surface we can draw a normal. Normally cuts the surface at what angle?
90.
90 degrees. So
Rectangle.
the first surface, we say we consider a ray of light. A ray of light from a given source striking the first surface of the prism, then it gets refracted, then emerge. Such that now this angle of incident is going to form, this ray, incident ray, is going to form incident angle. So we're going to have the incident angle I, and this one also we say emergent angle E.
They should be meeting.
I think that.
The number should be meeting.
Yeah. So you just join this one, you extend that normal, and you also extend the normal from the other surface, such that they are going to meet. Now, this is, which angle is this?
R1.
R1. This is R, angle of refraction. So you can call it R1, and this is going to be our
R2.
R2. Now, you deviate the rays of the incident rays as it is coming from magnetic source, which means you extend it. You do the same to emergent ray. You do the same to the emergent ray, such that they are going to form an angle here, and this angle that they formed here is what we call angle of deviation. This one is now what is called angle of deviation, and the angle of minimum deviation is now called this one. This is now the angle of minimum deviation. From the definition, what is angle of deviation? You can just read for me. Angle of deviation, what is it? So that we can understand from this. Angle of deviation, the angle of direction of incident rays between the direction of incident rays and the emergent ray. Angle of deviation first.
Minimum deviation and deviation.
Angle of deviation is what I want first. Now, angle of deviation, this is the definition. Angle of deviation is the angle between the direction of incident ray and the emergent ray. So you see the direction, angle between the direction of the incident ray. This incident ray is moving straight, and the angle between the direction of the incident ray and the emergent ray. When a ray of light passes from one medium to another, that is angle of deviation. Angle of deviation is the angle between the direction of the incident ray, and the emergent ray. When a ray of light passes from one medium to another, that is angle of deviation. Then angle of minimum deviation now is the smallest angle through which light is bent by an optical element. And in that case, that's why we denote this one as our angle of minimum deviation, which is denoted as delta M. Angle of minimum deviation. Now, angle of minimum deviation is the smallest angle through which light is bent by an optical fiber. Is the smallest angle through which light is bent by an optical system, or we can talk about optical element. Is the smallest angle through which light is bent. Now, so from the look of our diagram, we say this is our A, this is B, this is C. You can say this is M, and this one say this is N, and the second one is R. So I want you to see there is something unique happening here. So we are going to play with angle properties when deriving the equation relating to refractive index and angle of minimum deviation. So, are you seeing the quadrilateral AMNR? And normally, from the basic knowledge, you know that all angles inside quadrilateral angles add up to 360 degrees. Angles inside a quadrilateral add up to 360 degrees. Therefore, so you just say in quadrilateral A, M, N, R is equal to 360 degrees. How do we arrive in this 360 degrees? We take angle A, which is this one. You see angle A is the angle of the prism,
Yes.
Yeah, A plus angle AMN, which is this angle. Are you seeing that? Plus angle MNR, which is this one, plus angle NRA, which is this. So we are going to say angle A plus angle AMN plus angle MNR plus angle NRA RA. This one will add up to 360 degrees. Now we have angle A plus angle AMN. AMN. You see, this one is normal, and normally normal cuts the plane at 90 degrees. So which means here is 90, here is also 90. Therefore, angle AMN is 90.
Yes.
This is the surface. Though it is tilted. So this is the surface and this is the normal. Normal normally cuts the surface perpendicular, which is 90 degrees. So therefore this one is 90, this one is also 90. Therefore angle AMN is 90 degrees. So plus 90 degrees plus MNR, angle MNR which we don't have, plus
Plus
angle
90.
NRA. NRA is the same as
90.
90 degrees. This is equal to 360.
360.
So you can connect right term such that now we are going to have angle A plus angle MNR is
Equal to 180.
90 plus 90 is 180.
360
When 180 close to the other side of the equal sign is going to be 360 minus 180, we get
180.
180. So we call this one our first equation. So in this, after having this diagram in this form, we are going to play with the angle properties. Such that now, first thing we said, we are going to take quadrilateral angles with quadrilateral, which is this one. Now second, now we can take triangle.
Yes.
There are different triangles in this part. We have this one, MNR, MR. We can call this one, this point where they are meeting O. So, where this angle of deviation is, because this one when they view this immediate ray, and this one is also instant ray, they meet here. So we can call this point here O, and this one now is the angle. So this point O. So first of all, now we have the in quadrilateral AMNR is equal to 360 degrees, and we have arrived out 360 degrees is we can get this 360 degrees by taking angle A plus angle AMN plus angle MNR plus angle NRA, which sum up to 360 degrees. Then MNR is 90 degrees because this is a normal. A normal normally cuts the surface at 90 degrees. And therefore, since this one is 180, but now because of this surface, this one is going to be 90. But because of my drawing, it will look like it's not 90, it's more than 90. But it is something that you need to know. But when a normal cuts the surface, it cuts the surface at 90 degrees. So that is the first step. Now the second step now. So in that case, we are talking about in quadrilateral A, M, N, and R. So the next thing, you go in triangle M, N, R. In triangle M, N, R. You know that in triangle MR, triangle M, N, R add up to what? 180 degrees. It is something that we know that angles inside a triangle sum up to 180 degrees. And for this case, we have MNR is this R1 plus angle MNR plus angle R2 to add up to 180 degrees. So MR, which is R1 plus R2 plus angle
MNR. MNR.
MNR equal to 180
degrees. Make with the two questions.
Hmm?
Now the two equations can be equated.
What?
No, see, I
Angle
ca-
MNR is equals to 180 minus R1 minus R2.
now what you can do, see, there is an equation there which is also equal to 180. A plus MNR is equal to 180. Then you have another equation here, R1 plus R2 plus MNR is equal to 180. Now you can equate these two equations.
Yeah. So this one is first equation and this one is now our
Second equation.
second equation. In triangle MNR is the sum of triangle MNR add up to 180.